Okay, today guys, we are going to start a unit on counting principles and probability. And so we're going to start with the most basic idea, the fundamental counting principle. Okay, here is our first example. It's very basic. It says an ice cream store offers 3 types of cones and 31 flavors. How many different single scoop ice cream cones is it possible to buy at this store? So, I mean, if you think about it, if you wanted to write them all out, you might have like a cake cone of chocolate, a cake cone of vanilla, a cake cone of strawberry, a cake cone of each of the 31 flavors. But writing it out is a really long process because, I was going with one type of cone in my cake cone example, but there are 2 other types of cones, and so you would be writing a lot of those. Basically, it boils down to multiplication. You're going to say, okay, how many things have I got at this store? And I usually draw myself blanks. That's how I work. I've got 3 types of cones. I've got 31 flavors. And so I can just multiply those and get the 93 possibilities. The nice thing about this is, what if I had like 10 different kinds of toppings? Well, if I had 10 different kinds of toppings, I would just multiply by 10, so I would have 930 possibilities if I was just using one topping at a time. When you get into more toppings, it gets a little more complicated, but for right now, we're in the simple stuff. Okay, for our second question, we are going to talk about license plates, and it says, in a certain state, license plates display 3 letters followed by 3 digits. How many such plates are possible if repetition of the letters is allowed? So like I said, I make myself lines for how many, or kind of blanks for how many things I'm trying to fill, and I have 6 things here on the license plate. The first 3 are letters, and so you just have to go with how many letters are possible, and there's 26 letters in the alphabet. And repetition is allowed, so that means I have 26 choices for each case, because I could use A, and A if I wanted to, but I have 26 choices for each slot because none are restricted from me. And then the second part is the digits, and I have 10 digits. Some people want to go 9, but 0 is a digit, so that makes your 10th digit. And so you have 10 possibilities for each of the 3 digits. And since repetition is allowed, again, you have 10 choices. Nothing restricts those. And using the fundamental counting principle, you just have to multiply all that together and get 17,576,000 possibilities for license plates. Okay, I've changed this question just a little bit for the third example. And I'm saying in that state, we're still having 3 letters followed by 3 digits, but we're not going to allow repetition of letters. So if A is in the license plate already, it cannot be used again. So again, I like to give myself 6 blanks for what's going on. For the first blank, I have all 26 letters as a possibility. But for the second blank, I can't use whatever letter was in the first blank, so I don't have 26 choices anymore. I only have 25. And then for the third blank, I can't use either of the 2 letters that I've used before, so I don't have 26 choices. I have 24 choices. Because we don't know what letter is in each spot, but we're just talking about the number of choices for each spot. I didn't say anything about the digits, so I'm going to go back to having 10 digits as a choice in each of the last 3 places. And if I multiply these together using my fundamental counting principle, I get 15,600,000 possibilities. So it's a little bit less than what I had before, which makes sense. Okay, before we go to our last example, need to remind you about factorial notation. Let me get rid of this. Factorial notation is looks like an exclamation point. So if I said 4 factorial, that would mean 4 times 3 times 2 times 1. If I said 7 factorial, that would mean 7 times 4. 7 times 6 times 5 times 4 times 3 times 2 times 1. And we've worked with these in our class before, but if you've forgotten or if you haven't seen it before, that's how factorial works. If you're trying to write it for an amount that's unknown, so n, it would be n times n minus 1 times n minus 2 times, and I'm going to put 3 dots because it depends on how big that n is, and so I'm going to miss whatever's in the middle if there are ones in the middle, and the last 2 would obviously be 2 times 1 because you would always, multiply all the way down to 1. So that would be a way to write it if needed. Okay, for our last example, we have, in how many ways can a race with 6 runners be completed? And when we say be completed, we mean all 6 runners finishing. And we're going to assume no ties because, again, that makes things complicated. And right now we're sticking with basics. So 6 runners means I have 6 spots to fill. 1st, 2nd, 3rd, 4th, 5th, and 6th. And obviously a person can't be both 3rd and 5th, so you're not going to have any repeats in there. You have 6 options for your 1st place winner. And then you have 5 options for your 2nd place because whoever won 1st can't also win 2nd. And then you have 4 for your 3rd place, 3 for your 4th place, 2 for your 5th place, and 1 for your last place, because again, it's not about which person, it's how many choices you have, and each time you go down a spot you have lost the people who placed above that. And obviously this comes out to be the same as what I was just talking about a minute ago. It's a factorial. It's the same as 6 factorial, and you can locate the factorial button on your calculator if you do have a big number. Now this one isn't too hard to type in, but if you would get something much larger, on your calculator on the math key, if you go over on the top to PRB for probability, it's the 4th option down. It's where you can get the exclamation point. And 6 factorial, once you multiply these by either multiplying them out the long way or using your calculator, you end up with 720. Okay, this completes this lesson. If you'll start on your assignment.